Hey everyone, so this is lesson 4.4b. This is all about trigonometric functions of any angle. Specifically, we're going to learn about reference angles in this lesson, and then we're going to use those reference angles to evaluate trig functions. We're going to see how powerful and how helpful reference angles are when evaluating trig functions. So let's get started with defining reference angles. Okay, so definition of a reference angle, there's a couple words in here that are really important. So if we have an angle, so it says let theta be a non-acute angle in standard position that lies in a quadrant 2, 3, 4. Its reference angle is the positive angle, acute angle, theta prime. There's a little theta prime, there's a little like apostrophe after that, formed by the terminal side of theta and the positive x-axis. It has to be a positive acute angle. That's really important for a reference angle. It's a positive acute angle. It's formed by the terminal side of the angle theta and the x-axis, which is really important. A lot of times we use the y-axis by accident, and then we're going to get the reference angle wrong. It has to be from the x-axis. This week, we've been talking about drawing angles in standard position. We know to draw angles in standard position, we have one of the sides of the angle on the positive x-axis. And then the other side is called the terminal side that is going through the quadrants, could land in quadrant 1, 2, 3, or 4. And so the reference angle is formed by that terminal side and the x-axis. I think I said earlier by the positive x-axis. It doesn't need to be the positive x-axis. It can be the negative x-axis, like this first example we'll look at. Has to be the x-axis though. So let's check out this first example. These are 3 examples of how we're going to find reference angles. So let's say this first one, we have theta. Let's say this angle theta is 145 degrees. Notice that pushes it into the second quadrant. The reference angle, let's follow these directions. It's formed by the terminal side and the x-axis. So that pink angle is theta prime, and that is our reference angle that we need to find. We are going to find the measure of that pink angle, theta prime. Think about it. If I know this angle is 145, and I know halfway around is 180, in order for me to find just theta prime, the reference angle, we are going to do 180 minus our angle theta 145. So I get my reference angle is 35 degrees. That's the reference angle right in this piece. It's a positive angle formed by the terminal side and the closest x-axis. Let's check out the second one here. We have, and the example of theta is 230 degrees. So here's the angle we're working with, 230 degrees. That pushes it into the third quadrant. Here's where we commonly mess up. Let's try to draw and like spot out, get a visual for our reference angle. Remember the definition. It's formed by the terminal side and the x-axis, the closest x-axis. A lot of times you guys go for this piece right here, that angle. And that's wrong because that's formed by the terminal side and the y-axis. It has to go to the x-axis. So then we're looking to find how many degrees theta prime is, the reference angle. Let's think about this. All the way through that angle is 230 degrees. I do know 180 degrees is here. So we're going to do 230 degrees this time minus 180 degrees to get our reference angle theta prime is 50 degrees. So notice just the difference in the algebra. We have to do their angle minus 180 or 180 minus the angle, depending on what quadrant we're in. And then let's check out this last one for an example. Now we have theta is 300 degrees. That pushes it into the fourth quadrant. My reference angle, use the definition. It's formed by the terminal side and the x-axis. This is my reference angle, my theta prime. I know all of this is 300 degrees. This x-axis, I'm not going to use 180, right? Because that's not 180, that's 360. So I'm going to do 360 minus 300 to find this reference angle, which is 60 degrees. Okay, so we're going to do some practice of finding reference angles, a couple more here. Find the reference angle theta prime for each of the following angles. I like to draw, I like to get the visual. So let's see, 210 degrees. I know that's going to push it into the third quadrant. So then right away, when I look at that visual, my reference angle is 210 minus 180 because it pushed it past 180. So I get a reference angle of 30 degrees. Let's check out B. Notice now we're in radians, so we're practicing drawing an angle in radians. I know this is 0. I know halfway around the unit circle is pi, and in this case, it's going to be 4 pi over 4. If we're going to think about a common denominator to make this all fit, make it all make sense. I know one full revolution around the unit circle is 2 pi. If I get a common denominator here, that means it's 8 pi over 4, right? Because 8 pi over 4 is the same thing as 2 pi. Well, 7 pi over 4 is going to be right before 8 pi over 4. So here's my initial side, and my terminal side stops right before it gets to 8 pi over 4 because we're at 7 pi over 4. And so now I know my reference angle. I'm going to subtract 8 pi over 4 minus 7 pi over 4 to get my reference angle of pi over 4. This would be the piece that represents my reference angle, pi over 4. Similarly, let's look at 11 pi over 12. That's my angle. I know here's 0. I know this is pi. And in this denominator, that would be 12 pi over 12. 2 pi's over here, that would be 24 pi over 12. Well, if I'm drawing the angle 11 pi over 12, I know that's right before I get to 12 pi over 12. So to find this reference angle formed by the terminal side and the closest x-axis, theta prime equals 12 pi over 12 minus 11 pi over 12. That's going to give me pi over 12 is my reference angle. Let's check out D, 7 pi over 6. I know this is 0. I know all halfway around is pi, which is going to be 6 pi over 6. 7 pi over 6 is just pushed past pi. It's going to push it right into the third quadrant. So now that visual helps me see that for my reference angle, I'm going to do 7 pi over 6 minus 6 pi over 6. So my reference angle is pi over 6. Notice these are small angles. The definition of a reference angle, it's an acute angle. Pi over 6 is acute. Pi over 12, pi over 4, 30 degrees. These are acute angles formed by the terminal side and the closest x-axis. Let's look at E, 814 degrees. We're going to have to go around several times here, aren't we? So let's just start. I know it's going to go around one whole time. That's going to be 360. I know then we can have 450 degrees, 540 degrees, 630 degrees. I got to keep going, 720 degrees. So far, guys, I've gone around once and then twice. 720 plus another 90 is going to give me 810 degrees. And then if I add another 90, that'll give me 900 degrees is over here. 814 degrees is a little bit past that positive y-axis, so I'm going all the way here. That would be the proper way to draw that angle, 814 degrees, with that swirl, starting at the initial side, ending, rotating twice around through 360 degrees, stopping in the second quadrant. Let's remember the definition of a reference angle. It is formed by the terminal side and the closest x-axis. I bet some of you were thinking to subtract from the 810. Always go to the x-axis. So then that tells me I need to do, for the reference angle, 900. That's the closest x-axis, minus my angle, 814. And we're going to get 86 degrees is my reference angle. Let's just check out 3 more. Okay, 665, very similar to that one we just did. I know we're going to go around at least once. Let's keep going, 450, 540, 630, 720. So when I draw this angle, I'm going to go around one time, that's 360. Then if I start to go around, we're going to have 450, 540, 630, 665 is going to end up somewhere in that fourth quadrant. My reference angle, formed by the terminal side and the closest x-axis, tells me that we need to do 720 minus 665 is going to give me a reference angle of 55 degrees. Okay, notice all of these numbers, we're using the angle and the degrees on the x-axis. 15 pi over 4, that's a fun one. We'll have 0 halfway around the unit circle is going to give me pi, which is 4 pi over 4. All the way around is 2 pi, which is going to be 8 pi over 4. Let's add another 4, that's going to give me 12 pi over 4. Another halfway around is going to give me 16 pi over 4. So we've got one time around is going to be 8 pi over 4. 15 pi over 4 is almost to the 16 pi over 4, but not quite. That would be the formal way to draw that angle in standard position. So my theta prime, my reference angle, is going to be 16 pi over 4 minus 15 pi over 4. And we will get pi over 4. One last one here is negative 11 pi over 3. Remember, a reference angle is always positive. So let's just draw this 11 pi over negative 11 pi over 3. We've got 0, and then we go around clockwise, this time for a negative angle. So it's going to be negative 3 pi over 3 is over here. Then it pushes it up. That's going to be negative 6 pi over 3. Keep going. I'm going to have negative 9 pi over 3. And then all the way around again, we'll have negative 12 pi over 3. So, and when I draw this, notice we're going to go clockwise, which is the negative angle. So I'm going to start at the initial side, positive x-axis, going down and up. That gives me negative 6 pi over 3. And I'm going to stop here, which is short of me getting to negative 12 pi over 3. And so then if I do 12 pi over 3 minus 11 pi over 3, it's going to give me pi over 3. I just used the positive angle because I know a reference angle has to be positive. That is my reference angle for negative 11 pi over 3. Pi over 3. So practice finding reference angles. That's what we just did. Why reference angles are so powerful is because it helps us evaluate trig functions. I'll give you a moment to jot this down, and I will read it as you're writing it. It says, the values of the trig functions of a given angle theta are the same as the values of the trig functions of the reference angle theta prime, except possibly for the sign. So any angle is equivalent to its reference angle. The value of any angle for a trig function is equal to the value of its reference angle of that trig function. A function value of the acute reference angle theta prime is always positive. However, the same function value for theta may be positive or negative. So I'm going to show you what this means. I'm going to give you an example of what this means, and I'll show it to you on a calculator as well. Give you a second to jot it down. Okay, let's say we're working with the angle 130 degrees. So let's say theta is 130 degrees. You can visualize that. 130 degrees is over here. My reference angle is going to be 180 minus 130. So my reference angle is 50 degrees. So this is telling me that the trig function that I evaluate at 50 degrees is going to be equal to the trig function when I evaluate it at 130 degrees, and that is true. So let's say, for example, sine of 130 degrees. Let's figure out what that's going to be. And then sine of 50 degrees. Let's figure out what that's going to be. And I'm going to pull that up and show you. My calculator is in degrees. You can see right here. And we're going to type in sine 130 is about 0.766. sine of 50 degrees, its reference angle is also 0.766. So trig functions are equal based on their reference angles. Sines here are the same, and we can talk about why these sines are the same, as in like they're both positive 0.766. Because notice 130 degrees is in quadrant 2, we know sine is positive in quadrant 2. And then 50 degrees is in quadrant 1, we know sine is positive in quadrant 1. Let's do tangent of 130. Right away, tangent in 130, that's going to be quadrant 2. We know tangent is negative in quadrant 2, so we know that answer is probably going to be negative. And then tangent of 50 degrees. Let's see if these are equal values, just different signs, because 50 degrees is in quadrant 1, and we know tangent is positive in quadrant 1. Let's just change this to tangent of 130 and tangent of 50. Same value, one's positive and one's negative. Okay. And this, we're not going to use a calculator when we do these. This is just to show you what this was meaning, is how we use reference angles to solve the trig function of any angle. Okay, so let's do some practice problems here. Here are the steps first, if you want to jot them down. First, when we do this, you want to find the reference angle, just like we did right above this. If we were given the angle 130, first thing we did was found the reference angle of 50. And then we use the quadrant in which that angle lies in to find the appropriate sign, whether it's positive or negative, of the value, step number 1. And we're going to apply these steps to problems on slides 7 and 8. Let's just refresh our memory of our trig definitions using the unit circle. We know r equals 1. So that means sine of any angle is the y value. Cosine of any angle is the x value. Tangent of any angle is y over x. Cotangent of theta is x over y. Secant of any angle is 1 over x. And cosecant of any angle is 1 over y. Those definitions we should know. And now we're going to apply those definitions when using the unit circle, which you just learned about. And we're going to kind of put that unit circle to the test with some problems that we're going to check out here. Okay, so use reference angles to find the exact value of these trig functions. Okay, so very first step we want to do is find the reference angle. It's helpful when we find the reference angle by graphing it. So let's see, and you might not even have to, like we know 300 is going to be there. So my reference angle, I'm going to do 360 minus 300. So I know my reference angle is 60 degrees. I'm going to use that reference angle. So instead of finding sine of 300 degrees, because I don't know off the top of my head sine of 300 degrees, but off the top of my head, I should know sine of 60 degrees. And if you don't know off the top of your head what sine of 60 degrees is just yet, eventually you should have that memorized though. We are going to use the unit circle. And what we do on that unit circle is we're only looking at quadrant 1. You can memorize the whole unit circle, but everything you saw, the unit circle, it just changes the sign in the 4 quadrants, but the points stay the same. And so you can draw yourself a quick little quadrant 1 of the unit circle. And you know we've got 30 degrees, 45 degrees, 60 degrees. You know that's pi over 6, pi over 4, pi over 3. You know 45 degrees is square root 2 over 2, comma square root 2 over 2. 30 degrees is square root 3 over 2, comma 1/2. And 60 degrees is 1/2, comma square root 3 over 2. That should be memorized. So if your unit circle like sine of 60 isn't memorized, that part of the unit circle should be memorized. So then I know, and like I said, I don't know sine of 300 degrees off the top of my head. I'd have to memorize the entire unit circle. Sine of 60, I can just use that quadrant 1 of my unit circle. I go to 60 degrees. I know sine, the definition of sine is the y value. The y value at 60 degrees is square root 3 over 2. I go and check my quadrant I'm in. I'm in quadrant 4. Sine is negative in quadrant 4, so I know sine of 300 degrees is negative square root 3 over 2. And that's my answer. Okay, these problems piece everything together, everything that we've been learning. Let's check out tangent 5 pi over 4. First thing we want to do, let's get a visual. Let's graph that. 5 pi over 4 is going to be in the third quadrant. That means my reference angle, we're going to do 5 pi over 4 minus 4 pi over 4. And I get my reference angle is pi over 4, which is good. Pi over 4 is an angle in my unit circle. So now I'm going to do tangent of pi over 4. That is something we know off the top of our heads. Tangent of pi over 4 is 1 because tangent is y over x. Look at your y over x's at 45 degrees, pi over 4. And then I look at my sines. All students take calculus. I'm in the third quadrant. Tangent is positive in the third quadrant. So my answer is tangent 5 pi over 4 equals a positive 1. Let's check out another. Secant of negative pi over 6. My angle here is pushed downwards, and pi over 6 is already an acute angle. Reference angles have to be positive, so my reference angle is simply pi over 6. So I'm going to do secant of pi over 6. Secant, using our definition, is 1 over x. So I'm going to go to my pi over 6, and my x is square root 3 over 2. So I'm going to do 1 over square root 3 over 2. Again, it's a lot easier if that's memorized already, then I don't need to divide this. Then I'll have 1 times 2 over square root 3. Rationalize that, we get 2 square root 3 over 3. Think about my quadrants here. All students take calculus. We are positive in quadrant 4. So my answer is 2 square root 3 over 3. We're going to do 3 more, and then we'll be all done. Use reference angles to find the exact values of cotangent of 210 degrees. Let's first find our reference angle. If I draw that, pushes it into the third quadrant. 210 minus 180 gives me 30. So that means I'm going to do really cotangent of 30 degrees. If it's memorized by now, awesome. If not, let's use our unit circle. I know cotangent is x over y. Cotangent is x over y. Here's my x square root 3 over 2 over 1/2. And that's what I have to do because we have x over y. Square root 3 over 2 over 1/2. Divide this. We're going to get square root 3 over 2 times 2 over 1. So we get square root 3. And then we'll check all students take calculus. We are positive in quadrant 3 because it's the reciprocal function of tangent. So square root 3 is my answer. Let's do cosine of 5 pi over 3. If I draw that, that pushes into the fourth quadrant, not quite at 6 pi over 3. So then we'll subtract from 6 pi over 3, and we get my reference angle of pi over 3. So I'm really going to do cosine of pi over 3, which is easy. That's an x value, pi over 3. That's going to be 1/2 using my unit circle. And we are checking our signs. We are positive in quadrant 4, so my answer is 1/2, positive 1. One last one, we're going to do sine of 7 pi over 6. Brings us to the third quadrant, so I'll do 7 pi over 6 minus 6 pi over 6. So my reference angle is pi over 6. So I'm really going to do sine of pi over 6. Thinking about my unit circle, I need the y value at pi over 6, which is 30 degrees. The y value there is 1/2. Check my signs. All students take calculus. We're in the third quadrant. Sine is negative in the third quadrant, so sine of 7 pi over 6 equals a negative 1. Okay, lots of steps. This section, these problems really require us to put everything together that we've been learning. If you have any questions, let me know. If not, thanks for watching, guys.